our special guest. How are you doing?
All right, I'm good.
Good.
Jeremy Mazner on the management team. Only rule for you guys is look at Charles, not the camera. Is that right? That's the current guidance?
That's the current guidance. Pretend like the camera isn't here.
Everyone gets to look at my nose.
Yeah. So why don't you guys introduce yourselves first?
Oh, I'm Eugene Lin.
You're not looking at Charles, though. You're looking.
Oh, hey, I'm looking at Charles.
Yeah.
I'm Eugene Lin, and I'm lead PM for the DMI team,
And what is the DMI?
Device Management and Installation team.
Uh-huh.
And I'm Jason Cobb, the development lead for the DMI team.
Fantastic.
All right, so to someone at home who uses Windows, what is a DMI? How does this relate to them?
So what our team does is our team owns the infrastructure that supports device installation. So when you take a printer or camera or whatever and plug it into Windows, then all the stuff that happens between that and you being able to use the thing is what our team does.
All right, so I want to start with that actually, and maybe we can begin the whiteboard explorations, which is without going into actually how it's implemented, just the sort of list of tasks that has to be completed in order for a new camera, when you plug it in, take it out of the box, what has to happen before you can actually download pictures from it, say?
Oh, all right. Well, I mean, I don't even know if it's worth writing on the board. There's really only two things that have to happen. We need to find the drivers that work on the device, and then we need to install them. That's the only two things we have to do. And so the first part of finding them is actually the more interesting one. To find them, Windows ships with a bunch of drivers in the box, and so we can look there. If we can't find something there, then we can go look on Windows Update and try to download something automatically. In fact, today, if you're out there and you're running Windows XP, you can go out and buy one of the new Xbox 360 controllers, plug it in your Windows XP machine, and you will see it go get a driver from Windows Update. If we can't find something on Windows Update, then you get the Found New Hardware wizard, which makes most people think, oh crap, I'm dead now, it's not going to work. But Found New Hardware wizard comes up and says, put in your CD if it came with your device, and then plug and play. We will automatically go search the CD and find a driver if it applies, and then install it.
But now let's talk about that for a second. So when I stick a plug and playable device into the computer, how do you know what driver to look for?
So every device has a set of IDs, a set of hardware IDs on it. So these are embedded by the manufacturer, and they generally they're assigned by whoever owns the bus. So for example, all USB devices have a specific format for their IDs, and there's is it a SIG or something organization? Is it Microsoft that assigns IDs for those things?
Sort of. It depends on the bus. The way it works is, for example, PCI, there'll be a vendor ID and a device ID, and then there's like a subsystem ID and a revision ID. These are just IDs in the space on the device, and Microsoft takes all those IDs, concatenates them together in a certain format to create a bunch of hardware IDs. And then what it'll do is it'll add like all four of those members together to create the most specific ID, then it'll kind of lop one off to create a less specific ID, it'll lop two off to create a more generic ID, and so on until you get to something very generic like, I'm a PCI video card.
So what plug and play will do then is, every driver for a plug and play device has a list of IDs that are contained in it. So there's the INF file basically defines the driver package. So it's just a text file that basically lists, here are all the hardware IDs that I work with, and then here's a set of instructions as to how to install the driver that is in me. And so we'll go compare those IDs against the IDs in the hardware, and then decide which one matches best, where we'll try to match the most specific driver against the most specific ID on the device. And then on top of hardware of ID matches, we also look at the version of the driver to find out whether the one you're installing is newer than the one you've already got. We look at who signed the driver. So if it was signed by Microsoft, it's considered better by default than drivers that are signed by third parties. And if it's signed by a third party, it's considered better than not being signed, because Windows can at least tell that the package hasn't been corrupted if it's been signed by some third party, and Windows can verify that.
And if it's signed by Microsoft, typically that means it's gone through the WIGL quality bar,
Yes.
so it won't blue screen your machine.
So if it's signed by Microsoft, it means it has either been built by the Windows Build Lab, and so it's gone through the similar testing to everything that goes in box, and if it's been signed by WHQL, it means it's passed Microsoft test. and Microsoft tests are intended to improve the quality of drivers.
Fantastic.
That's interesting. You said intended to improve. Maybe we'll get back to work on it a little bit. We should probably ask a question first, which is
Turn off the camera.
Yeah. What is a driver? Why do we need a driver?
All right. I mean, this is for developers, right?
Yeah.
This is for developers.
Yeah, but
We're developers. All of us.
But probably the most generic level, a driver is just software that you need in order to make your device work. It's software that interfaces with your hardware to make it work. You have an OS layer. The OS layer can't talk directly to the hardware because there's too many differences between every piece of hardware out there. So the driver just kind of translates between what it needs to know and the hardware.
Okay.
And that's all it really does. Most drivers run in kernel mode, but a lot of drivers are now running in user mode as well. So drivers can run in different modes like that as well. But that's basically what a driver is, just the specific software you need to get your device working.
So does every device have a driver? A unique driver? That's a leading question, maybe. But
A unique.
I'm thinking
No,
of
I mean,
class drivers and that kind of stuff.
Every device needs software to run. The OS does have built-in support to make some things run. Trying to think of how to explain this better. It can be as generic as like the VGA driver. Most display adapters will work with the VGA driver. However, that's kind of a bad experience. So you really want a more specific driver that'll make your video card do all of its special bells and whistles, and you can play games and graphics go real fast. So every device does have a driver, but it doesn't necessarily have to be a unique driver. But usually the more unique or specialized the driver is, the better the software, or the better your experience will be. The more you can make use of that hardware.
Certainly.
So how does, for something like the VGA drive that's supposed to work across multiple hardware, is there some common spec for what a VGA card has to support, and the driver just sort of works against that
Yes.
lowest common denominator?
Yes. Yes, and they're trying to do that for other bus types as well in the future. For instance, for cameras, they have the, what is it, MTP? Is that the new standard, Eugene?
Yes.
So this new standard called MTP, which is just basically a list of interfaces on how you would communicate with the camera, or how the OS would communicate with the camera. The OS ships a base MTP driver. And so if you have a camera and that's all you really want the OS to do is talk MTP to it, then you don't even need to provide a driver, which can save companies lots of money. They would only then need to provide a driver if they're doing something above and beyond what our standard driver does.
So here's one way that I like to think of it. I don't know if you can see this. That if you think of like, here's the sort of here's the kind of functional stack, and so you start with some hardware, and let's just say abstractly the hardware exposes some set of functionality. So there's a set of functionality that's considered common. So for example, I'm a printer and I can print, and so that's common functionality. Microsoft will have a driver. There may be a driver that can work with all printers, and as long as every printer exposes the print functionality in the same way, that driver will work with it. So in the example Jason was citing, if you've got a digital camera that meets our MTP protocol standard, then our MTP driver will work with it. And then Windows talks to the driver, and then apps can go through our APIs to go use that functionality.
Okay.
Now sometimes what happens is a device will have additional functionality that Microsoft didn't think of or decided not to support. So in this case, say your printer can tell you how much ink it has left, and our driver didn't really define any way of doing that, and there's no API that you can call in Windows that says, am I out of ink or not? And so what vendors have is they have two choices. They can either say, oh well, we built a bunch of hardware that we can't sell, or they can create another driver. And so in this case, what'll happen a lot of times is that they'll create a driver that actually supports the extra functionality. But now since Windows doesn't have any common APIs to expose the functionality, then they also need to ship an app that just goes and talks directly to the driver, or maybe through some general mechanism in Windows to talk to the driver. So this is why with a lot of devices you get, there'll be like something in the taskbar, and you'll be like, why does that thing have to be in the taskbar? Or you'll be like, why is the thing installing an application? And it's often because the vendor is trying to expose something that the hardware does, and there's no way to do it in Windows without shipping an application that talks directly to their driver to do this.
Interesting.
So but that application that's not a driver. That really is,
So,
it's a separate
I mean,
Win32 application.
Depending on who you ask, the term driver can mean almost anything. We generally use the term driver to mean it is a It is the thing that Plug and Play installs and loads that is related to the dev node for the device. And for most end users, what driver means is driver means all that crap I can't see, right? It's stuff that got installed that wasn't in the start menu. I don't see anything in the taskbar. I don't see anything on my desktop, so it must have been a driver. And then if anything else shows up outside of that, they go, why did this install this crap? I just wanted a driver. And so there isn't really a one crisp definition of what a driver is.
Very interesting.
We have a new term we're using called driver package, which kind of contains all of the files that you're talking about right now, including the little applets on the tray and stuff like that. Because to our vendors, all of those pieces of software are extremely important. A printer company, for instance, thinks that if you don't have their tray up that allows you to hit their copy button or that shows you if you're out of ink, then the experience isn't their full experience, and
Sure.
they view that as a failure if all of those pieces aren't present. So
Absolutely.
yeah,
So
the
you're-
term, just the kernel driver nowadays is not enough for most of our vendors.
Sure.
They really need the full experience.
Because you want to be able to manage
Yep.
the hardware.
Yep.
So hardware demo. So here's a great example here. So this is a printer that I have in my office. The reason I have it in my office is because Windows includes drivers in the box to make it print and scan. And
Okay.
so that all works fine. Of course, with the driver in the box, if I hit the Start Scan button, nothing happens. And that's because the driver in Windows doesn't support that, because Windows doesn't have any API support to do that kind of thing. And so I could install the driver from HP in this case and get that extra functionality. And then there's sort of a split in the world of people who feel that if I bought the device, then I should get everything that came with the device, because that's what I bought. And then there's another set of people who say, I bought the device, but I want as little software as possible to make that device work with its basic functionality. And one of the big issues we face now, the tension between us and our partners, the tension between partners and customers, and the tension within Microsoft is, what's the right trade-off there? What do you do to a user who says that? And I kind of see it as like, an analogy is, if I go to the doctor and I say, I want to be faster, right? One doctor is just going to say, well, you should exercise more. And another doctor might say, we're going to replace your legs, right? We're going to put in bionic implants and do whatever. And depending on who it is that's asking or what it is you want, both may be the right answer. So Plug and Play is in the unenviable position of having to make that choice generically for hundreds of millions of Windows users every day. And we work with thousands of partners in trying to make all of this work and trying to come up with a consistent message for our users and for our partners.
Yeah. And also, you also do a very good job of, if you happen to plug in a device that doesn't have a driver, that information can be sent to Microsoft, to you guys, and you can figure out what a driver is and then put it out in a service pack and put it on Windows Update.
Yes, and that's actually, it's something that I actually think, hey, let's turn this off. It's something that I actually think is really cool, because if you look at the application world, right? If I say, I wanna go like mail pictures to somebody, then there really isn't much help that Windows gives you in terms of finding applications that let you do that. You can go out on the web and search for things. You can go to the Windows catalog and sort of look around at things, but there isn't anything kind of automatic that happens. You double click on a JPEG and it opens in Paint, and you're like, well, that's what I get. Whereas with Plug and Play, we have a way of automatically hooking you up, given that you have a device, with whatever software is best. And then we have our ranking algorithm for figuring out what's best or not. And that's in contrast to the app world, where if I install Music Match Jukebox, all my music files belong to Music Match Jukebox. And then if I install Windows Media Player, they all belong to Windows Media Player. And there's no smarts in Windows at all about deciding which one goes with which application. But in Plug and Play, we do all of that stuff for you.
So is Plug and Play is implemented
I
as a
think it's
Windows
really close.
service?
Huh?
We want to hear you better.
So yeah, Plug and Play is it's a Windows service, and then it's a set of DLLs that run in the application context as well. And so one of the things we're actually doing in Vista that's different than previous versions of Windows is, in previous versions of Windows, for example, the Found New Hardware wizard would actually do the work of installing your driver. That is, if you're an administrator and you log in, and the wizard comes up, the wizard would actually copy the files into the System32 drivers directory. Which was simple, but it also has the side effect that means any other application can do the same thing, or IE can do the same thing, or a batch file you write could do the same thing, or your kid running up to the keyboard could do the same thing, and that didn't make for a very stable system. So what we've done in Vista is we've actually, the plug-and-play service, which runs in as local system, does all of the work of installing drivers, and actually does all of the work of actually copying drivers onto the machine. And that means that applications that call our APIs really go through the thin layer that says, are you allowed to call me? And then if you are allowed to call me, then our APIs will RPC into the service and tell it what to actually do.
Excellent.
So maybe let's try and draw it up on the whiteboard if we can. It'd be interesting to really draw what happens, the sort of flow chart of you plug a device in. Let's say it's your printer, right? So you need maybe the class driver, maybe you need the special HP software. And I guess maybe it's worth diagramming it in the new Vista world. What actually, everything that has to happen from the device showing up on the USB chain to getting the software.
Yeah, there are a lot of pieces involved, especially the kernel mode pieces as well, which we've kind of been glossing over. Our team doesn't own the kernel pieces, so if we exclude them a little bit, that's why.
All right, so you're just going to draw and you're going to keep them honest?
Yeah.
All right, so we have, so first I'm going to split this up into two contexts. So there's the user's context, and that's basically everything that runs as you. I'm logged in as Lin, and so everything runs there as Lin. And then there's a non-interactive context, which is the service context.
And you guys have filed all your patents already, by the way, right? We're not going to disclose anything that...
Correct.
All right.
We've either filed them or we miss a deadline. We're all good. And then there's kernel, right? So when a new device shows up, so then we'll say, let's say plug in. So this will be time, okay? So you plug in the device, and the first thing that happens is the kernel goes and detects it and does stuff. And here, I'm just going to call this magic, because this is outside of our team. Okay. So magic happens and notifies us that there's a new device. And so at this point, what happens is...
And it tells you that whole device ID we're talking about with the vendor string and the class name and all.
So what happens is the kernel will actually go detect the device, read the information out of it, and then it will go spew some stuff in the registry that says, here's the device ID, here's the bus it's attached to, and then it will notify the plug-and-play service that something has happened. There's a new device and you should go pay attention. Okay. And so at that point, the plug-and-play service will wake up, and what it will do is it will go search for drivers. So actually I'm going to introduce a term here. So in Vista, we've added something called the driver store. What the driver store is, it's not a store like Safeway or something like that. The driver store is a directory on the disk where we stage driver packages before they're installed. Another way to think of it is like, if you're installing Word, then what happens is Windows just copies all the Word files from the CD into the place they're supposed to be in. In the driver world, we used to do that, but in Vista what we do is, imagine that we copy all the things needed to install it to the disk first. Then we'd actually do the install from that location to its final destination. The reason why we do it is actually, there's twofold reasons. So one is, if you have to like repair it, you have to uninstall it, you have to do something like that, we know we've always got all the source available. So you don't get a random prompt that says, please point me at p379.dll. Because what happens is people will point us at a file that has that name that isn't the right file, and then bad things happen. Sure. The second reason why we do this is because there's a set, we want to be able to control who's allowed to add drivers to the machine independently of who's allowed to install drivers on the machine. And this happened because our enterprise customers were saying, it's really not a good solution when my laptop users have to be administrators on their machine to like plug in a printer. And so those enterprise administrators said, we want a way of sort of putting the printer drivers on the machine, but then letting anyone who's on the machine actually install them after the fact. So the driver store kind of lets us do that. So back to the diagram.
So when you install a driver, is it per user or is it per machine?
So when you install a driver, installing a driver is always per machine. Staging a driver is always per machine. Everything to do with drivers is per machine, much to the chagrin of our customers sometimes, but it is always per machine. So what Plug and Play does is Plug and Play will search the driver store. The driver store contains, this is a crazy diagram. The driver store contains all the inbox drivers, so there's no more drivers.cab. It also contains OEM preloaded drivers. It can also contain stuff that your admin preloaded. And so these are also actually new things we've added in Vista. So an OEM or an administrator can point at a Vista image that hasn't even booted yet and add drivers into the driver store without even having to boot the image. So for guys like Dell, for example, it saves them massive amounts of time to not have to boot a machine in their factory. So Plug and Play will first search the driver store. And then if we find something, then we'll actually go do the install. So if we find something, then we'll install. And what happens with install is install actually creates a new process, which is our dir inst process. And the reason why we create a new process instead of having the plug and play service just do it itself is because during install, we actually will call out into co-installers. A co-installer is basically a DLL that lives in your driver package that has arbitrary code that we will run in the local system context. And so as you can imagine, because this code comes from outside of Microsoft, we wouldn't have a good design if we just assumed that that code was always perfect. So what we do is we launch this separate process, and we launch our install area there, and all of the calls into the co-installers happen within this process. And meanwhile, this guy makes sure that this process has been running for less than a timeout. So we have a timeout that's like 5 minutes now. And what that timeout is there for is in case something goes wrong and that installer process hangs, then we'll just kill it so that your machine actually continues to work. If we didn't do that, what would happen is any bug in a co-installer would mean all the plug and play would stop working on your machine for the rest of the time. And so we wanted to avoid that.
Why aren't you running it on a different thread? Or is that not what you're saying?
We run it in a different process so that it is isolated from everything that our plug and play service is doing.
So then why? Okay, fair. I was just confused about why then it was so bound to this process here.
It's not. What happens is this process will just go. This process actually just goes and launches this process with a command line that tells it what to go install.
Understood.
So that's it. And by the way, no one else should ever do that. Our service should be the only one that ever does that. So if we...
Can you protect against that? Or what happens if a user just types in dirvents.exe?
It has to be running in the system context. So we do protect against that way. It has to be running in the system context, and you can't easily launch something in the system context.
A user would have to create a service that runs in the system context that then goes and calls it. And if that happens, then duck and cover. Bad things are going to happen.
Oh, that's PR.
Hey Tom, are we approved? I'm in the middle of a TV interview actually right now, so could you send me email with yes in it? Just reply to the mail and someone will send it to you. Okay, bye.
That's the way work gets done. That's the process.
So if we don't find a driver in the driver store, then we need to go do something else. We're not going to give up at that point. And so what happens is we will go here, and then we will go launch our, I guess we'll call this our client process. And so what our client process will do is it will go look in a couple other places. So it will go look in a thing called device path. So device path is it's something that's been there for a while. It's a registry key that tells Windows, it points Windows at a number of directories to go look for drivers in. So in previous versions of Windows and as well as in Vista, an OEM could also just like create a directory, C/drivers, put a bunch of drivers in there, and then set the device path registry key to point there. A common usage of it is in small business scenarios. A small business will have a network share that just has, all of their drivers sitting on it, and they'll just configure all their machines to point at that share so that Windows can find a driver. The reason why we actually go out to the client process instead of looking in the service is because we want to make sure that we can get to this network share, and that may require user credentials, it may require a connection or something like that, so we actually go out to the client process to do that. So we'll go look in device path, and we'll also go look at Windows Update. Again, Windows Update this is totally configurable. You can configure Windows Update. You can configure Windows to not go to Windows Update. You can configure it to ask you before it goes. You can configure Windows to go to a corporate software update service, a corporate SUS server instead of Windows Update. But we'll go check Windows Update and try to install something. If we find something at this point, then we will go back down into the service and do the install. Again, we do the install in the service to make sure that none of your apps can go mess with it.
Understood.
If we can't find anything there, then we will go launch the found new hardware wizard. So the found new hardware wizard will actually prompt the user, and it will prompt the user to put in either a disk that has a driver, or it will give the user the option of browsing to a location to go get the driver. Assuming we find a driver there, we go back down and do the install. I'm sort of glossing over a little bit here, but I'll get back to that. If we don't find a driver there, there's one last resort, and that is we use Windows error reporting. So for those of you who aren't familiar with Windows error reporting, you know whenever IE crashes and it says, do you want to send information to Microsoft? So we're actually hooking into that same infrastructure, and we're treating I can't find a driver as an error. And so if we can't find a driver in that case, we will create a Windows error report, and that Windows error report will include, among other things, the plug-and-play ID of the machine and the architecture. So
Now it also happens when Firefox crashes.
it happens actually when any application crashes, and so in this case we will go create a Windows error report. And the cool thing about Windows error reporting in Vista is you don't always just get the dialog that says so-and-so has crashed. What happens is you just get a little thing of progress that says we're uploading some stuff, and then we send information back to Microsoft. What we do with Microsoft is we actually, still in the works right now, are going to provide a way for our hardware partners to log into the WHQL site and view all of the information about what things people are trying to plug into Vista so that they can make decisions about their own customers. At that point, they have the option of either giving us a driver to put on Windows Update, which would be ideal, or giving us something to show the user. Usually a URL that redirects them to their website to download a driver, but it could be things like a message saying, hey, sorry, this product is out of its support cycle. It could be we're going to give you a discount on buying a replacement product or something like that.
Sure.
And if for the device you've plugged in there is already a solution set up, then the user will see it immediately. So the user will say, I don't have something, and then boom, we will show them the solution.
So
if Vista's running now, I can show you. Let's see if it is. Hey, look at this.
Wait, which build is this though?
Oh, I can't show it?
If it's newer than 5231,
Oh,
you
yeah.
can't show. Unfortunately.
All right. You didn't see anything.
Okay. Well, that background is available for the people.
Yeah, that's fine.
So
All right.
we're not cutting that out.
We sadly cannot show the new
Yeah.
hotness
We don't
of
like
the
to add it
show.
on
So much cool stuff behind there, but you're
Absolutely.
missing it.
But just wait.
Okay, so this is sort of how install works, but I'm sort of missing a part here. So in this case, the driver's already in the driver store, so we can go do the install. It would be very dangerous for us to attempt to install a driver that is sitting out here on a CD or somewhere else. The reason why that's dangerous is because, so I'm a user, right? And we have to assume that the user is doing all kinds of bad things. The user has 20 pieces of malware that are constantly trying to kill their machine. The user has a web page open to the head of the Communist Party and that's monitoring everything that's happening on their machine. And so we need to make sure that our install process doesn't get corrupted by anything that's happening in the user's context.
Okay.
So what we do is, there's actually two places. So here or here, there's a step that I missed, which is add the driver to the driver store. Sorry, I'm left-handed, so I block
No
everything on the
problem.
right.
Watch the hand.
So, in cases where we find a driver, but the driver is not already in the driver store, the first thing we do is we actually add the driver to the driver store. Then we go install it from the driver store. And so, adding the driver to the driver store actually turns out to be a way more complex process than you would think it is.
All right, wait. We got the diagram was gone. But one thing I wanted to ask on that last diagram was co-installer. What's an example of why someone would need a co-installer?
Okay, so an example of why someone would need a co-installer. So one example is this. If I'm installing a device, let's say I'm plugging in, let's say I have, let's make up a new device category. So I'm installing a device that is a heart monitor, right? And in that case, Windows does not have a standard heart monitor API. There's no standard heart monitor class driver. You're totally out in the weeds here. And so in this case, if I'm a partner doing that, then I can write a driver that sort of drives my heart monitor. But the thing is ooh, look at Charles. Okay. So I can write a driver that drives my heart monitor. But
We're looking at Jeremy.
all right. I can write a driver that drives
So
my
say it one more time now.
So I can write a driver that drives my heart monitor, but I need to have something that actually lets the user get to that functionality, right? It's no good to say, hey user, there's some kernel APIs that you can call now if you want to use your heart monitor. And so an example of one thing you might want to do is, let's say there are a bunch of applications out there that already look for heart monitors, and those apps might already be on your machine. But one thing you may want to do in your co-installer is check to see whether the application's there, because maybe you need to tell it. You need to set some setting that says, I'm a heart monitor and I'm available. So that's a case where you would do something with your co-installer, or you could. because there's nothing in plug and play that kind of supports that operation, and so you would provide a co-installer that goes and does that work.
So you're just giving ISPs, driver companies, the ability to implement an interface, install interface, and then jump into your install process and add their own custom code. That's what you're saying?
Yes. Plug and play at its core really says, based on this hardware ID, copy these files, copy these registry keys, and set these properties. And if there's anything you have to do outside of that, then the co-installer is kind of an escape hatch to do that.
Sure.
We designed the mechanism back in, correct me here, Jason, if I'm wrong, Windows 2000, was it, that we introduced co-installers?
Yes.
So in Windows 2000, we introduced co-installers because partners said, there's some things here I can't describe in terms of copying files or setting registry keys. So we introduced co-installers in a sort of ill-fated decision that said that co-installers run just like our code. A co-installer could do anything that our code does. A co-installer runs with all the permission that our code runs in. And because of that, we're actually very, very careful about situations where people have to use co-installers, and we'd really like to eliminate those if possible, because co-installers are something that could actually cause an install to fail that are out of our control.
So how do you give a company, like, let's say I write a printer driver, how do you give me the flexibility to say, well, I want to do much more than you're doing in your installation?
Often what we found is there are things that partners will do with co-installers that they actually didn't have to do in a co-installer. One great example is a common thing that we've seen in Vista that people will try to do with their co-installer is they'll have two devices. And they'll have a device that really looks like two devices to Windows, and they'll have two different driver packages. What they'll do is they'll have the first driver package installed, and then they'll have a co-installer that goes and tries to find the second driver package out on the source media and then copy it to the machine manually. But we actually have a directive in the INF that lets you do exactly that. You just have one line that says copy inf equals and then the name of the other package, and plug and play will do it all for you. And so we've gone to a lot of these partners and said, hey, it turns out you didn't have to write all of this code, and you don't have to have a co-installer that does this. We already have a mechanism there for you.
So you brings up an interesting point. What is the anatomy of an INF?
So an INF is kind of, so format-wise, an INF is pretty archaic.
Is it worth trying to bring one up to look at?
Sure.
Should we hide your desktop for a second while you?
Can you turn?
Sure. Let me.
Wait.
That's.
How about we talk about the history of the INF file? Because they've been around for quite some time. Well, INI files have been around, and INF is a flavor of INI. Is that right?
Yeah. INFs predate me at Microsoft. I think they actually came about in Win 3.1. You can install some device drivers with INFs. They really took off starting with Windows 95, where that's how all plug-and-play device installs would happen, is through INF files. And they've kind of grown since then. But how an INF looked in Windows 95 isn't that different from how an INF looks today. And it's pretty interesting. We always think they're so archaic, and we always bring up to the vendors, once every OS cycle, hey, should we come up with a new format? And they say, absolutely not. We know INFs, we understand INFs, they work back a couple OSs, we like them, just keep them. So as much as we would like to come up with something new, the vendors love them because they know what they are now, and they happen to work for the last couple OSs.
And then theoretically, so what that means is you could have the same INF work on 2000 and XP.
Yes.
Okay.
Yes. Which is very important to all of our customers.
Does INF always mean a PNP install file, or are they used in other ways?
You can use them in other ways, but that's kind of going away more and more in Vista. You can use an INF just to copy files and make registry settings and stuff like that, but you would more than likely use MSI or something a little more robust than INFs. INFs were originally designed to set up the OS and to set up device installs, but they do have some generic APIs that anyone could use if you want to, but I wouldn't really recommend people do that. It's much harder to debug than using something like MSI or Install Shield.
All right.
Okay.
We're up.
So let's take a look at this INF here. So this is one of it's an INF that is actually included in Windows XP. You'll see that it refers to Trident because it actually was authored at some point by Trident Microsystem to support their hardware. So here, in the first part, what you'll see is an INF is split up into sections like any INI file. So the first section is a version section. This tells us generic information about the package. Signature line tells us that this is a Windows 95 or Windows NT package.
Chicago being the code name.
Yes. Provider tells us which company provided the INF. What you'll see in a lot of places is this % string % notation. What that notation means is it means for the INF, it's a way of doing string substitutions. So down at the bottom, you'll see in the strings section, there is a list of these little tokens as well as the actual string it turns into. The reason why we separate them out like that is to allow for localization, so that you can have a string section that's for French and a string section that's for English. Sorry, he was about to impale Jason with the other end of this camera.
Sorry, Jason.
Okay, so back up to the version section. So layout file is actually, it's an internal thing that used to be there in Windows XP. It was one of the weirdnesses about inbox drivers, so we fixed that in Longhorn by getting rid of it, or in Vista by getting rid of it. Class and class GUID tells us the setup, the device setup class of a device. Now, people will often mistake this to mean it's sort of the category of the device. Like if you're in a store and you're looking down the aisle at different categories. People use it to mean that because Device Manager shows it that way, but a device setup class really means a device setup class is a category of devices that install in the same way. So the fact that something is in the display setup class, for example, doesn't necessarily mean it's a display device that you look at. What it means is it's a device that, when installed, has to do all of the things that all display devices do. That is it. So you could, in theory, have something like a fireworks launcher that is a display device, because Windows talks to it as if it was a display device, but it doesn't actually look like one at all.
Thus the term class.
So that's the term class. And there's actually two things here. So there's a GUID, which identifies the class. Microsoft defines a set of system-defined class GUIDs, but vendors can also add their own. And then class here is just sort of the friendly display name for it. One thing you'll notice is, why is it that the IM specifies both of them? Shouldn't there be a way of associating the name with the GUID one time? The answer is, yeah, if we had it to do over again, we wouldn't have done that. But that's the way it works today. Driver ver tells us the version of the driver. You'll also see that there's, in addition to the standard sort of crazy multi-part Microsoft version, you also have a date. The reason why we added the date is because that was a lot harder to mess up. And we actually have cases where partners will come to us and say, we accidentally set our version to the maximum possible value. So we added the date as a way to validate very easily whether somebody was doing something wrong or not. And so Plug and Play will actually look at the date before it looks at the other version part.
The dates are also valid between different companies. Every once in a while you'll get, for instance, there could be a Microsoft driver inbox for the Trident video card, and then Trident could have shipped one themselves. And in those cases, Microsoft's versioning scheme could be very different than the company's versioning scheme, where the dates are always the same. If Microsoft released its driver in November 2000 and the third-party company released theirs in November 2001, we'll choose the newer one. It's a way to span across different vendors.
So the next section you see here is called destination DIRs. What this tells Windows is, where should I put the files that are listed in this INF? So default is, it tells us the default place to go. And in fact, these numbers here are kind of redirection numbers that tell us where to put it. So in fact, I'll bring up the MSDN article here. So there's an MSDN article called Using DIR IDs. Got it, everyone? Everyone use MSN search to find this. So you find Using DIR IDs, and this thing actually lists all of the number values we have and what those mean. So if you want to copy something to the Windows directory, please don't say C:\Windows. Use %10%, because Windows will make sure that always points to wherever the Windows directory is. So we've got that for a number of common directories that drivers have to write in. So, yeah, so in this case, you don't use % in the destination DIRs, because the way the format works is we're expecting one of those numbers. So this tells us that everything in the section called tridxp.miniport should go into the drivers directory, and then everything in the section named this goes into the system directory. Next, we actually get in kind of the meat of it. You can think of an INF as a tree. So what you have is you have a list of manufacturers, and then under each manufacturer, you have a set of models. I guess I should just say this. So So you've got every inf has a set of manufacturers in it. Wow, I don't know why I wrote that. It's got a set of manufacturers. Every manufacturer has a set of models in it, and then every model points at what we call a DD install section. And so this is really the section that tells you what work to do. And then within each DD install section, you have copy files, you have add reg, you need to add registry, and a couple other lesser used operations. So this is kind of how plug and play decides what to do. Plug and play says, well, here's an inf, here's a set of manufacturers, here's the model, and then associated with a model is in fact a set of plug and play IDs. And then based on that plug and play ID, there's a set of instructions that says, here's what to do to make that plug and play ID work.
So when you put an inf into the driver store, we never finished that discussion, but you have to essentially index and say, hey, here's all the P&P IDs that this particular inf supports.
Yes, that's actually a very good point. Whenever you add a driver to the driver store, we in fact do go parse the INF to figure out what hardware IDs it supports and then index it so that we can find it quickly. And in fact, today in Windows XP, when you plug in a device and you get that kind of long delay of badink and then stuff is happening, that stuff happening is us kind of cracking open all of the inf files and looking around to find plug and play IDs.
So it's not indexed at all on XP. You have to.
It is indexed to some degree, just not very well. And so we're making it better in Vista.
Think these will ever be written in XML?
It is.
That goes back to the other discussion about what's
we thought so too, and we asked vendors, and it was pretty much a unanimous no. We were quite surprised.
It took them long to get those regular expressions all fine-tuned.
Exactly.
Okay.
Right. So you can see that the manufacturer section has kind of the name of the manufacturer, and that points at the models section. So the model section here is named this. So plug and play says, oh, here's the name. I'm going to find a section that has that name. Now that section contains the display name of the device, and then the name of the DD install section, and then the plug and play ID that model belongs to. So now let's say we're going to go down to the install.
So this one's, just so we understand, this one is set up and says, hey, even if you have these devices different, they're slightly different for what machine you have, but the driver is the same.
Right.
For both of them.
Right. So what this does is it's two different devices, and the reason why they define two different ones is because there's one that should be named Toshiba and one that should be named HP. But both of them, in fact, do exactly the same thing. They both point at the TRID XP install section.
But it was actually very good of the vendor to create two separate IDs here in case in the future they ever had to do something different on a Toshiba machine versus an HP machine. Right now they behave the same, but if HP needed something special done that required a separate driver, they would have been screwed if they used the exact same ID for both vendors. So it's very good that they did that.
Interesting.
Another way to think of it is if you've got 5 kids and you think you're always going to treat them exactly the same, you give them all the same name, and then one day you decide that you want to do something for kid number 1, but he doesn't have a different name, and so there's no way to call him. That's why we want everyone to have different plug and play IDs. So now we go down to the DD install section here, and this thing has one line which says copy files equals blah. What the copy files directive means is go to a section named this and copy all those files. So you can see here that this section says copy this file, and then this section says copy this file. So we will find those files and copy them into the destinations that were specified up here in destination jars. You'll also see that there's a services section. So what plug and play does is plug and play says, well, my DD install section was named TRID XP. So I'm going to find a section that's called that name dot services. And this means this is the actual kernel mode service that gets installed for that device. And so here you can see the name of the service, some flags about how the service should start. 2 in this case means it's a plug and play device. And then pointers to sections that tell plug and play what to do.
Is it common for a driver to need a service?
It's actually, most drivers do have services to set up like this. So what will happen is, in fact, on a Windows machine, if you go take a look, take a look at services, then you will actually find it. I'm not going to find the TRID XP service here, in fact, but I will find other ones. So, actually, I guess I don't know the names of any of the services on this machine that drive driver devices, so never mind.
You won't see them for that. It's just 32.
Okay.
So services actually date a little history back when NT first started. Everything was a service. Kernel mode services ran devices, and user mode services were also available as well. When plug and play came around, it still kept the service. It still kind of used the services. That way it was easy for kernel mode to load plug and play drivers or legacy drivers the same way by always looking at the service key. Although if you were to design this today, you wouldn't necessarily need a service. You would copy the file and we would just know what file it is that gets run. But that's why services are still used this way.
But these are services for install time only, or these are actually, you need that Trident service to run?
This is actually the thing that loads, that runs the device.
This is the main driver for the device.
Okay.
It's also called a service.
But it won't show up in the device management service manager.
No, because it's a kernel mode service versus a Win32 service.
So it doesn't service to UI.
Exactly.
It runs in non-UI context.
So anyway, down here you can see the section that describes how the service should be installed, and then as well as some registry entries that get added apparently to do something with the event log. Looking elsewhere in the driver, there's some other settings, and you can see all of these are just registry keys that they're setting. And you can see that most of these things are things that are specific to either a display device or to this particular device. And because INFs are very flexible, you could do literally anything from here in terms of any registry key or any file. And then the last thing you see, as I mentioned before, is the strings section. So in this case, there's only one string section which lists everything in English. But what you would see is a vendor could actually create multiple string sections. Each one, a string section, for example, would look like this, where this is a language, locale ID, in this case English. And what plug and play does is plug and play will find the string section that matches the language you're running in, and then use those instead of using the default one. And it'll use the default one if it can't find anything that matches. So
That's very interesting.
very fast overview of what an INF file looks like.
Great.
So what else do we need to know about how the device gets sold? We didn't talk about the extra software, like if you're talking about your HP Scan Now button.
So one of the things that we've actually debated a lot inside Microsoft, and one of the things that we don't feel that we've really solved well yet, is this question of what is it that Windows should do when you plug in a device. So I'll draw kind of two different cases here. So in one case, I've got my this really cool thing. In this case, we have Microsoft hardware created a keyboard that has a fingerprint reader on it. And so Windows does not have a generic driver for keyboards that says I can drive a fingerprint reader. In that case, the team has created a driver for their fingerprint reader, but they've also created configuration applications that let you use the fingerprint reader to save passwords on web pages, for example, and to log in. So in that case, when you plug in the device, if we really want to make it just work, we would put all of the software on the machine, including those configuration applications, because the set of users that bought the device but don't want to use the fingerprint reader is probably pretty small. And so in that case, it seems like a clear-cut case where the user bought the device, you should let them do everything the device does. On the other hand, let's say that a partner decides that in order to help their business, when you install their webcam, then they're going to install Gator, and they're going to install, some kind of long-distance phone call application that has nothing to do with the device. If we provide a mechanism that lets vendors install applications or any other software with their devices, then we kind of open up the door to that. And it means that even though it's really not Microsoft's call as to what partners do with their products, users will come back and not like us. And so we've been grappling with ways we can do that. Is there a way you can offer the user a choice? And in particular, it's easy to offer the user a choice when the partner wants to give the user a choice. But if the partner doesn't want to give the user a choice, is it Microsoft's position to force a way of giving the user a choice? And that's actually a really tough call. And it's a hard technical problem, but it's actually a much harder business problem. And so we've been wrestling with technical ways that we could solve that, but there's a lot of business work and a lot of legal work that has to happen to settle all of that. And because of that, as much as we want to be in this world where everything you plug in just magically works, there's really no good definition of what just works means. And so we try to do the best we can without opening up security issues, without really introducing the likelihood of horrible scenarios happening, where you plug in a device and you get all kinds of things you never wanted.
But couldn't you make that part of the WIPO process? For example, so if I created a device in order for me to be Microsoft certified, I have to show that I'm not installing rootkits for my DRM solution, right? So,
For example.
For example. So,
no one would
is
ever do that.
Of course not, but that's just an extreme example.
I'm definitely not reading the brand name on this camera.
Okay. So, well, ding. Cool. So let's speak to that. So what are some of the, let's talk about the technical solution now that we brought up rootkits and stuff like
Okay.
that. But what is the technical solution to a problem as though that we just
Okay. Well, actually, I'd like to go back to the point you mentioned about WCL before.
Sure.
Why can't WCL test together?
Okay.
So there's two issues. So one is, while WCL is something that we encourage partners to go through, it's not something that every partner does go through.
Define it quickly.
Oh, sorry. So WCL stands for Windows Hardware Quality Labs. A couple years ago, what was happening is Microsoft said, wow, we're letting all of these partners write drivers and write applications that run on Windows because they're drivers, but there's a lot of them are really low quality. A lot of them are crashing. A lot of them are making Windows look really bad. And so our users are saying, we would like to have some way of knowing that this is better. Kind of like the FCC for your radio, or kind of like the underwriters laboratories for your electric devices. So Microsoft introduced this lab as a way of, and introduced it with the Design for Windows logo program. And the idea was, if you buy a device and it's got the little Windows flag on it and it says Design for Windows, it means Microsoft has done some testing on it to make sure that your device is not going to harm Windows and it's going to function well. So a lot of people will ask, why can't that program just solve all the problems in the world? So the first issue is you need to have a reason for partners to go through it, right? If I'm a partner and I have a choice between I can ship whatever I want, or I can only ship the thing that Microsoft lets me ship, then I have to have something that balances out that cost. So that's a tricky issue that we've been working with, that we and the WHQL team have been grappling with. The second issue is how do you actually test it? Because what we're really doing is we're taking partner binaries and we're just running them. And so it's very hard to test for things like, what if you've got code that, on a machine that is named this on the 4th of July 5 years from now, it's going to blow up and do something harmful to your machine. And without asking for source code from all of our partners, which we can't do, we don't have any way of guaranteeing that we're preventing any of that bad behavior.
So you just have to have faith in the device manufacturer that they're not going to harm consumers.
Right, and luckily, in capitalism, vendors who do horribly bad things don't survive very long. So we do rely on the market in some cases for things like that.
Especially in the day of the blog. Right?
Yes.
Quickly gets out there.
Yeah.
So I just want to quickly mention that we are at T-minus 7 minutes left.